This is exam video 6, prompt 1. So we're explaining positive inducible control today. Here's a diagram. What is positive inducible control? So it's positive because the activator protein that binds to the DNA increases transcription. It positively affects transcription. It's inducible because the small molecule that interacts with the activator protein induces the activator protein to be able to positively interact with DNA to positively increase transcription. So how does this work? Well, it starts with having a weak promoter. There's some operon that we need to transcribe, and its promoter's weak. It can't really recruit RNA polymerase like it should. So we have an activator protein that comes in, and this is made by transcription and translation, an activator gene that can help the promoter recruit RNA polymerase. But it can't do it by itself. So we have a small molecule that comes in and interacts with the activator protein to induce it to attract RNA polymerase to the promoter to start mRNA transcription. And this complex, this activator and small molecule complex, binds to the activator binding site. Hey everyone, I'm Kat. I'm an activator protein. Hey guys, Kat behind the camera. So this is the operon that I'm trying to get going, but for some reason, I just can't stick to this binding site. Someone's up. Okay guys, so I googled it, and apparently you need a small molecule to help you bind to this activator binding site. I mean, like, who knew, right? But I think I just found my small molecule. Hey guys, so now that I've got my small molecule, we've binded together, and now we're a complex. Hey everyone, it's Kat and small molecule, cyclic AMP. Now, hey, we just got to bind, woo, to this activator binding site. Now we can get transcription going. Okay, y'all, new mission. So, now that we've binded, we gotta recruit some RNA polymerase. And I think I know just where to find some. Hey, polymerase. Can I help you? Well, I was thinking that you could help me transcribe an operon. Alright, I guess I can help you out. Let's go. Alright, now RNA polymerase will bind to the promoter and zoom, transcribe. So here's a diagram of positive inducible control. Thanks, Kat, for helping explain. So we've got our small molecule here that will bind then to the activator protein. The activator protein binds to the activator protein binding site, and it helps the promoter recruit RNA polymerase. So RNA polymerase binds to the promoter and then transcribes these structural genes that are down here that will create protein products that our bodies need. Up here, we have an inactive activator because there's no small molecule, so it cannot help transcription turn on, so transcription's off. This slide just represents what was analogized in the video. Thanks!